Okay, so let's do a little review of the sine curve. So sine t, and we come out here at 2 pi, and mark that in half, and half, and half, and then we're going up to 1 and down to -1. A quick little review of the sine curve. And we said, okay, it looks something like that, But we said, well, it also goes to the other side. So let me see if I can mark that off. Whoops. Down here at -1 and back. And it keeps going, you know, like we could keep going further. But here's the thing. We said this is not a one-to-one function, and so we have to restrict it. We're going to restrict it between here. Oh, sorry. Let me draw that. We're actually going to include that point. And here. Now you might say, well, I didn't want to restrict it that way. I was thinking to restrict it between 0 and pi, right? But see, it wouldn't be 1-to-1. It still wouldn't be 1-to-1 there. And you say, well, okay, well, I want to restrict it between, you know, pi over 2 and 3 pi over 2. Well, you could do that, but we don't. So we stay within the first quadrant and then the fourth quadrant, okay? So you're going to, for inverse sine, it's going to be restricted between negative pi over 2 and pi over 2. Okay? One, we want them to be consecutive so that we have this smooth, continuous curve here. And we have to have both the positive signs and the negative signs, or we'll lose some of the angles, right? Okay. So I think of it sometimes on a circle, it's these two quadrants right here, the fourth quadrant and the first quadrant. And then you can get reference angles to all of them in either the first or the fourth quadrant. You couldn't do first and second because you'd only have positive sign values there. So you have to have the fourth quadrant to get the negative ones in. Okay, we're going to write this all up at the end. All right, now for cosine, let's do a quick review of cosine. Here's 2 pi, pi over 2, 3 pi over 2, going up to 1, down to -1. And remember, it starts at 0, 1, and then it goes down, 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 up, and up. Anyway, that's the cosine curve. And so a similar thing kind of has to happen. Now you can say, oh, well, we can go in the other direction. You can, and you can keep going in this direction too, but we need it to be 1-to-1. We just need a section that has the positive and the negatives. And so we're going to restrict that between 0 and pi. And that's going to be the first and second quadrants. Okay, so this is for cosine t. Okay, and that's going to be this section right here. Okay, so the restriction for the inverse of cosine, so inverse cosine of x, that's going to be between 0 and pi. Again, we want to get the positives and the negatives. We want them to be consecutive. We want it to be within one time around the circle. If I tried to use first and fourth, like for sine, then they would all be positive cosines, and I need the negative ones to be represented. Okay? Now, there's more detail on the graphs of the functions, the restrictions, and the inverses. If you want to see how they reflect about the y equals x line, you can see that. Those are in the book. Okay? And then I wanted to do tangent, so I'm going to draw that in. So if you remember tangent, we were here at pi over 2, we were here at negative pi over 2, and we had asymptotes. And then we had a curve that went something like this, okay? Now, remember, that continues. So like out here at 3 pi over 2, there was another asymptote and another curve, you know, and it's periodic. It keeps going in both directions. So what we really want is we want just one of those. And so for just one between the asymptotes, that's 1 to 1. So we're okay there. And so the tangent, inverse tangent of x, that's going to be between negative, we're going to take this one, the first and, or the fourth and first quadrants. So we're going to go from negative pi over 2 to pi over 2. But notice that we're not including the asymptotes, okay? So that's going to be restricted that way, all right? Now, we're going to write it all up nicely for you here. So for inverse sine, let's see. And so we have to have y in the way I have it written. So if you have sine y equaling x and y is between, well, I wanted to write it with the interval notation, and y is greater than or equal to negative pi over 2 and pi over 2. And that's the interval for negative pi over 2 and pi over 2. Now notice this time we have the square brackets unlike the tangent curve, okay? And that's going to be then the range, right? For inverse, okay? I'll try to write the next one better. So if you have angles between in this interval, 0 to pi, and again, we're including those endpoints, and if cosine y equals x, then inverse cosine of x equals y. Okay? So that's how that one works. And then for angles in the interval, but we don't include the endpoints this time. Negative pi over 2 to pi over 2. If tangent y equals x, then inverse tangent of of x equals y. So we have to restrict it. This is how they wrote it. I have seen it written this way too in other textbooks. So, you know, they a lot of times will use the interval notation as well. Okay, so that's a long video, but hopefully you're getting the idea on how it's restricted so that it'll be a one-to-one function for the original function, and then the inverse function, then you can do the inverse function.